Okay. And with here, we know how to find the area, right? So area first is equal to B, which is the width, and then it is going to be C minus Y. Why C minus Y? Because if you look at this variable over here, C is equal to half H, right? We want to find this area. So in order to get that area, we know that the width, so what you have over here is usually the width and then the depth, okay? So the depth over here, this distance is equal to C minus Y. Okay, before we go on, how do we know what is the width and what is the width depth? As I did explain before last week, okay, the axis of interest is ZZ, right? The axis of interest is ZZ. So if we look at our equation number 1, we have Vy over what? IZZ. So ZZ is the axis of interest. Anything that's parallel is known as our width. Anything that's perpendicular is known as our depth. Same like bending moment. Okay, we did not change anything. Okay, so then the interesting part is this. Okay, we have C minus Y, and it's not Y minus C because it's positive. So if you look at the defined area, right, the defined area is starts from the Y max, right? So this distance from here to here, right? This is Y max. Okay, that's Y max, right? And then it starts from Y max and then it comes towards the what? Centroid. I.e., I repeat again, the analysis starts from Y max. That's why you have C over here, right? The C is where let me write this out. Okay. Note C is also equal to what? Y max. Yes or no? Right? It's your Y max. So in this context, the analysis direction starts from Y max. So what I'm drawing now, that arrow over there, hold on. Okay, this arrow that just drawn is the analysis direction. Okay, that's the analysis direction. So we come up with uh rule number 3. Okay, so rule number 3 is that the analysis starts from the distance or the perpendicular distance furthest away from the centroid. Okay, from the global centroid. So this becomes our rule number 3. Oops, sorry. Okay, our rule number 3. So what I do, I'm going to go to the next page. I will need to copy this diagram. And I will copy this equation over here. So we found our area. Next, we want to determine our y bar. Okay, we are going to determine our y bar. So y bar is equal to C plus y multiplied by half. Okay, so that's our y bar, and so y bar is this y bar that we are looking for now. Okay, and some of you might ask why C plus y multiplied by half. So I'll give you an example. Do not memorize this, okay? If this is equal to 3, right? And this, and then the next one, this is equal to, wait, let me think. This is equal to 5, for example. Okay. So without doing any calculation, right? You know at C or C prime, this is equal to 4, right? You agree, right? I hope you do agree. And why is it equal to 4? If you look at observation, yeah, Eugene, I agree, equal to 4. But if you do the math, it's going to be 5 plus 3 multiplied by half is equal to 4. Okay? That is how you find your y bar. Okay, so now we can form the equation of QZ is equal to B C minus Y, okay, C plus Y multiplied by half. Okay, and then when we simplify this equation, okay, when we factor this equation or simplify, whatever you want to call it, you know that this is 0.5 B C squared minus by Y squared. Okay, then from here we are going to set rule number 4. Okay, rule number 4. Okay, we're going to set rule number 4. Because this is the global centroid, and at the global centroid, this is where we have our datum. Okay, that is where we have our datum. Then we can state this: the first moment of area right? The first moment of area cannot cross over the centroid. Okay, the first moment of area cannot cross over the global centroid. So that becomes our rule number 4. Okay. And then finally, rule number 5. Okay, you will have your Q. So Q is our shear flow. Okay, so this is our Q. Right, and we realize that the Q, rule number 5, the shear flow Q, okay, can only flow in one direction. the shear flow Q can only flow in one direction. Okay, now we are now going to see how these rules work. Okay, how this rule will work. Okay, so I'm going to draw a situation. Okay, well, we are going to draw our situation, our condition. Okay, so by applying this, I think the first four rules first, the fifth one later on where there's situation, then we'll apply the fifth one. Okay, so let's look at this first. Okay, let's apply these rules first. So if we have our cross-sectional view, let me. Okay, so if we have our I beg your pardon. If we have our cross-sectional view, okay, and remember the 5 rules. Okay, so what I'll do is I'm going to gather all the rules together. Okay, so rule 1, we're going to put them all together. Okay, we're going to put in rule number 1. And we're going to apply these 5 rules. Okay, rule number 1. Then we have rule number 2. Okay, where the datum is at the global centroid, rule number 2. And then we have our rule number 3, where the analysis starts from the perpendicular distance furthest away from the global centroid. And then we have our rule 4. Okay, the first moment of area cannot cross the hold on, I should not be pasting there. The global centroid cannot, the first moment of area cannot cross the global centroid. And finally, Q can only flow in one direction. This one we will apply later. Okay, I think the first 4 is more critical for now. Yeah, so these 5 rules. We are now going to apply the first 4 rules first. Okay, but since I'm here, I put all of them together now. Okay, so rule 1, rule 2. Okay, so I'm going to sketch a cross-sectional area. Okay, so this will be our Y, Z. Okay, and the cross-sectional area that we're going to look at looks like this. Okay, this is a cross-sectional area. And I'm going to declare that this is the position of the global centroid. Okay, so this is our global centroid. Okay, and again, I'm going to give you different situation. Okay, so if we are going to now find, right, the stress state at point alpha over here. So where is the first moment of area we're going to take? Okay, so we know that the analysis, okay, so